Hello, everyone. The purpose of this recording is to develop a code written in both MATLAB and Python to perform matrix multiplication. Of course, both Python and MATLAB have already built-in utilities to compute this matrix multiplication, but it's a very instructive exercise on nested for loops to learn how to write a code yourself that does the matrix multiplication. So let's get started with reviewing the concept of matrix multiplication. If we have a matrix A whose size is m times n, and matrix B whose size is n times q, where the number of columns in A equal the number of rows in B, then it's possible to perform matrix multiplication. And in fact, the results C is going to be a matrix whose size is m by q. M by q. So let's recall how is this performed. Let me write a general matrix A. So it starts with A11, A12, all the way to A1n, because there are n columns in matrix A. The second row here will be A21, A22, all the way to A2n. And you can write actually a general row in matrix A. So in general, any row in matrix A is going to be I1, AI2, so it's row number I, all the way to AIN. Again, what is I is just a general number, general row number, because we know that this is row number 1, this is row number 2, and this is row number I, and the last row, the very, very last row is row number n. It's going to have AM1, AM2, all the way to AMN. But really, please notice that general, general row in the matrix A. Now, for B, allow me to write it in a column fashion, because I will be concerned with multiplying the rows of A with the columns of B. So allow me to write B in a column fashion. So the way I'm going to do this, the general elements of the matrix B are going to be B11, and then I move to the second row, I will get B21. And if I keep going down, I will go to row number n. Remember, the number of rows of B is n, row number n, and that's Bn1. Let's write the second column. The second column is going to be B12, B22. And as I go down, I will reach to the nth row, and that's the second element in the nth row. Now, if I want to write a general column in B, it's going to be, let's give it some general notation here. So it's column number J. So it's going to be B1J, right? It's the first element in this column. The second element is going to be B2J. Remember, it's column number J. If I enumerate the columns here, this is column 1, this is column 2, ... and then there is a column J, and then eventually there is column number Q. Remember, the number of columns of B is Q. So let's continue writing the elements of our column J. So B1J, B2J, all the way to BNJ. Finally, if I keep going to the last column, I will have B1Q, B2Q, and then eventually I will reach to the column, to the last element here, which is BN and Q, right? So that's basically the general element in matrix, the general columns of matrix B. And again, I was interested in rows of A and columns of B. Now, how is the multiplication is performed? Let me focus on this. Basically, the idea is that you take every row in A and multiply it by all the columns of B. Similarly, you take the second row of A and you multiply by all the columns of B. So in a sense, you need to loop over all the rows of A. And for each row of A, you need to loop over all the columns of B. So that in itself requires two nested loops. So in a sense, you should have a loop over rows of A, that loop is gonna run from, from 1 all the way to M. Remember, the number of rows of A is 1, 2, 3, all the way to M. And inside this, there will be another loop over columns of B, and that one is gonna go from the first column to the column number Q. So this is from 1 to Q, okay? Now, what happens inside these loops? Basically, you calculate, remember that the final answer is C. And if you want the first element in C, which is C11, that's gonna come from the first row in A times the first column in B. If you want C12, so that's gonna come from the first row in A and the second column in B. If you want C, C34, so it's gonna come from row number 3 in A and column number 4 in B. So in general, if you want a Cij, it's gonna come from row number I and column number J. That's why I was insisting on writing the rows of A and the columns of B, because the first index comes from the row. The first index for C is coming from the rows of A, and the second index is coming from the columns of B. So basically, let's try to calculate a general element Cij. It's gonna come from the multiplication of row number I times column number J. So let's do this. So in general, the element Cij is, so let's do the multiplication carefully. Remember, AI1, that's the first element in row I, so AI1 times the first element in this column, which is B1J, plus the second element here is AI2, and the second element in this column is B2J, plus, keep going, what's the last element? The last element in the row I here is AIN, and the last element here is the BNJ. Notice something. All the elements coming from A, so this element and this element and this element, have the same first index, which is the row index of A, because they are all coming from the same row. Similarly, all the elements of B, so B1J, B2J, B3J, and so on and so forth, all the way to BNJ, have the same index, which is J, because all of them are coming from the column J in B. The indices that change are, the second index in A and the first index in B. So it starts as 1 and then becomes 2 and then becomes 3 and then becomes a 4, and eventually it's going to become N. Remember, what is N? Well, N is a common number. It is the number of columns in A and the number of rows in B. So I can actually write this as a summation. I can write the element, so let me do this here. The element Cij is a sum that starts from 1 and it ends at N, and basically I'm calculating what? I'm calculating AI, so I need to put an index for this loop. Let me, for example, choose an index K for K from 1 to N. So I need to multiply AIK times BKJ. Remember, the I and J are fixed. I is the row number from A and J is the column number from B. But K keeps varying. It starts from 1 and it goes all the way to N. And if you remember the trick of calculating sums, the sum itself is some sort of a loop, right? The sum itself is in general is some sort of a loop, which will appear clearly in the MATLAB. Okay, so that's it. If you think about an algorithm, I need to check that whoever is using this code is inserting the matrices such that the number of columns of A equal the number of rows of B. Otherwise, we should give an error message. And then I have 3 nested loops, one loop over the rows of A and a loop over the columns of B. And inside this, I might need a loop to calculate this sum. And that's it. I'm done. Let's actually do this. let's actually do this. Let's start with actually coding in MATLAB, and then we move to Python. So now, based on this explanation, let's develop a MATLAB code that performs the matrix multiplication, and we are gonna test this code as well. So I started a new file which I named my_mat_mult because I'm gonna define a function with the same name. The function needs an output, a matrix C, and it has to be called my matrix multiplication as well, and it needs as an input A and B. I might need to check the columns of A equal the rows of B. So I'm gonna use the size function in MATLAB, so size of A, so let me call this little a, and little b is gonna be the size of the matrix B. So remember, the size actually function for a two-dimensional matrix like this is gonna give you an array, a tiny array, where it's gonna contain m and n. That's for the matrix A. The number of rows of A is m and number of columns. And similarly, B is gonna be n and q. Hopefully, you are hoping that this is gonna be n and this is gonna be n as well, right? Otherwise, you cannot perform the multiplication. And if you remember the way MATLAB indexes the elements of a row, this is gonna be basically A1, write this correctly here, this is A1, and this is going to be A2, right, as an array, elements of array, and this is going to be B1, and this is going to be B2. So I need to put an F statement here to check the possibility of performing this multiplication. Let me clear this drawing here. So I'm gonna, or actually, let me bring it back just for a second. Basically, I want to do this F statement, check that multiplication is possible. It's always good to comment. So if A2 does not equal B1, then I need to write a message for an error message here and stop the code. Basically, I'm gonna say to the user, size doesn't allow multiplication. So hopefully the user will understand what we mean here. So if we bypass this F statement, then it's possible to perform the multiplication. And as you have seen, I need 3 loops. Let me actually clear this, clear all the drawings here. I need 3 loops. Big loop over the elements of A. Okay, big loop. And the rows of A, the general element in the rows of A is going to be I. So I'm going to loop for I equal 1 to the number of rows of A, which is M. I didn't define M and Q and N. Right now, they are stored in the tiny arrays A and B. So let me define them here. M is the number of rows in A. That's basically A1. So let me write a comment here. Number of rows of A. I have also N, which is A2, right? Which is the same as B1. Is number of columns of A, which is the same as rows of B. And finally, I have Q. Q is B2, and that's basically number of columns of B, just as we explained on the right on the board here. So let me save this. So this is basically is a loop over rows of A. There is each loop has to have an end. I have another loop inside from J equal 1 to Q, and that's essentially a loop over columns of B, and it has to have an end. What do I need to do inside? I need to sum the element. I need to calculate every Cij, but every Cij is a summation, and we learned that a little trick to perform a sum is to define a variable. We call it sum. We set it 0, and every time we add on top of it these elements. And after we calculate the sum, we would say, hey, we are done with the sum. Let's assign this Ci. this, let's call the Cij. Again, I need to calculate the sum, and that in itself requires a loop from 1 to n, and gradually summing these terms. So let's do this. I'm gonna set sum equals 0 at the beginning. I need to initialize the sum is 0. And then I need to loop from 1 to how much? To n, right? And I need to say that sum equals sum plus this term here, a I k, let's not make a mistake here, times b kj, k and j. And of course, we should put a semicolon, otherwise MATLAB will keep printing this. And this has an end. After I calculate the sum, I'm going to say, hey, my C of I and J is sum, right? Is the summation that I calculate. And then the loop, I'm going to go outside second loop, basically, go to the next column, to the third column, to the fourth column, to the fifth column, until I finish all the columns of B. And after that, I'm going to go to the outside loop to move to the next row in A, and then to the next row in A, and so on and so forth. So let's actually, I think we are done here. Let's do a test here. Here, all CLC. So let's try some tests, you know. Let's take some matrix here, 1, 2, 3, 5, 6, you know, anything minus 1, 0, 9. So that's matrix A. Matrix B is going to be 9, 2, 3, 0, minus 1. Of course, we can use this with any sizes. Actually, let's try 2 rows, just 2 rows, and see if this is going to work. Obviously, MATLAB is going to complain, right? Because the matrix dimension doesn't match. Let's check our code actually can recognize this, that there is an issue in this multiplication. Yes, error using my mate_mult. Size doesn't allow multiplication, of course, because our matrix B has 2 rows only. Let's actually define, you know, some matrix. Let's call it E. E is 1, 4, 5, and you know, minus 1, 0, 9, and 7, 7, 6. So remember that this is A, and the previous one is E. If I calculate A times E, it's gonna give me this number. That's the built-in function in MATLAB. Let's try our code, but of course I need to put E here. So let's test it. Does the same answer as MATLAB? Yes, it's the same answer. Okay, so the next step is to code this in Python, and I'm gonna use a spider here for this purpose. I can save this file as I wish. I don't have to call it my matrix multiply, but you know, let's call it my matrix multiply, although I don't have to. In Python, it has to be .py though. I need a couple of imports. So from NumPy, I'm gonna import the shape function, which is similar to the size in MATLAB. I probably need also to import the array function. And because I need to have an error message and stopping for the code, so I'm gonna import sys as well to allow me to stop the code if the dimensions of the arrays, the matrices don't match each other. And let me save this. Basically, let me start the function. The function is called matrix multiply, you know, or my mate multiply. It doesn't matter. I don't have to call it this name, but just for consistency with MATLAB, it takes two inputs here, which are A and B. I probably now need to check or to get the size of A and size of B. So let me call little a is the size of A. And so sorry, it's the shape of A. Yeah. So this is the shape of A. And little b is the shape of B. And similar to MATLAB, is basically our arrays that are going to store the number of rows in A and number of columns of B, except that one exception here is one has to note that the list here that's called A, its first element, so it's Mn, so its first element is going to be A0 and its second element is going to be A1, because in Python we start counting the indices from 0. So let's put our F statement. So the F statement here, and I need to indent here, if A of 1, which is the second one, the second index, is not equal to B of 0, then the conclusion is I need to put an error message here. So I'm going to put a sys exit, and between this, I'm going to put an error message. So matrix multiplication is not allowed here, basically to inform the user that the size is not matching. And that's of course, Python doesn't have an end statement for F. I just need to indent carefully. So if we pass this F statement, then we can actually compute stuff. But let me define M, Q, and N. So M is the number of rows in A. So it's basically A 0. Let me write a comment here on this. Rows of A. N is A1. That's basically columns of A and also rows of B. So these complaints will disappear in a second. And then finally, I will have Q, which is the columns of B. That's basically B of 1, small b of 1. So that's basically, let's like a comment here. This is columns of B. Now I'm ready to do the nesting. So for the nesting, I'm going to say for so for I in range of N, so that's basically a loop over the rows of A, and another loop inside for J in range of, that's a loop on the columns of B, so range of Q. What do I need to do? So instead of, of summing, of using the sum variable trick we did in MATLAB, so Python is providing these modifiers, these arithmetic modifiers. So I'm going to use them right away. So for A in range of the last loop is on N, basically C, capital C of I and J is going to equal, instead of equal, I'm going to put plus equal. That's actually equivalent, to adding to itself. So it's going to add to itself. So I'm putting plus equal. So it's going to add every term on top of each other. So that has to be A of, I and K times B of, I'm just doing this here, times B of K and J. Okay, and yeah, that's it. I'm done with the 3 loops. There is no need for ending in Python. I'm gonna basically go back to here. I'm still within the function, right? So here I probably need to return to the user the value of C. To test this, to test that this actually works, or I probably need to define, so it's complaining here because I didn't define C. So I can actually define C right away using zeros. I can define initiate Z by zeros, but I need the zeros function from NumPy. So after I passed the F statement, I could actually define C right now after I finish the F statement. So I can see that I can say that the matrix C is an array which in general is a floating point, so it's real numbers, and it actually it has how many rows. I need to say how many rows and how many columns. It has m rows and 2 columns, right? But I can actually do this. I should do this. Let me cut. I should do this after the MNQ definition here. So this way, so it's sorry, this is not array, this is zeros. This has to be zeros. I think now it should work. To test this code, we can, we can write any matrix A. So A equals an array. So I'm going to start with a list, and that list is of a floating point. So I need 3 rows inside. So let's say 1, 2, 3. The second row is -1, 2, and 4. Did I import array? Yes, I did. And then 9, 0, -1. Just any array, any matrix A. Let's copy this and do the same thing for a matrix B. And so let's put different numbers, 6, 2, 5, anything. So -7. Let's make this 10, just different array. So I'm not going to use the function now. All what I'm going to say is to use the built-in function in Python. So .amp, and let's print C and see what's going to happen. Oh, I didn't import dot, so let me import dot here. I'm going to run now. Let's clear the window. So basically, this is the result coming from the built-in function in Python. Let's test our code. So how are we going to test this? I'm going to comment this out. And instead of using the dot function, I'm going to say that C equal my matrix multiply of A and B. So let's see if this is going to work and give me the same answer. Yep, it's the same answer. So perfect. So we finished developing a Python code and a MATLAB code to perform matrix multiplication. Thank you so much, and see you in the next video.